All right, first of all, let's talk about the difference between a Taylor polynomial and a Maclaurin polynomial, and there's not a huge difference other than where it is centered. A Maclaurin polynomial is automatically centered at x equals 0, and a Taylor polynomial can be centered anywhere, including 0, but if it is centered at 0, we could just say it's a Maclaurin polynomial and not tell you where it's centered, and you'd automatically know, okay? So based on the video you just saw and the things that you have just kind of expounded on, you realize that there were a lot of factorials that matched the term number, starting with the 0th term, and also the exponents matched the term number. So, and the order of the derivative matched the term number. So here goes. Let's write some stuff down. A Taylor polynomial centered at x equals c is of the form, is centered at x equals c, and is of the form p sub n equals, all right, and this would be the nth degree. And if you want to say, let's do this, of x, it is, here we go. All right, the very first term was simply the function evaluated at c. If you want to get really technical about it, for the sake of the pattern, and I will do this a lot, you would also have x minus c to the 0 over 0 factorial. Just quick, in case you've never seen it before, or if you saw it and forgot it, 0 factorial is not 0. We are not dividing by 0 here. 0 factorial is 1. Fun times. Plus, next term, first derivative. So this is the 0th term, so I have a denominator of 0 factorial, an exponent of 0, and the 0th derivative, which is the original function. And now I have the first term. Now I know that's the first term, but we're counting here. So 0, 1, so f prime of c, x minus c to the 1 over 1 factorial. Now there's a lot of unnecessary stuff in here, like the understood 1, the understood 1 here. That's really equal to 1. That denominator is equal to 1. That's equal to 1. But I like the order of it, just the structure. So second derivative, where n equals 2, which is technically the third term, and that's x minus c to the second power over 2 factorial, which is equal to 2. But we'll put the factorial for the sake of the structure. You can see where this is going. So f third derivative evaluated at c, x minus c to the third over 3 factorial. And this goes on and on and on. Where does it stop? It stops when you get to the nth term, whatever n is, whatever they tell you. If they say, hey, find the 10th degree Taylor polynomial, then you would go all the way to 10. It might take a while, but it would be this. F nth derivative evaluated at c, and I'm going outside the box here. Well, let me erase some lines so it works, or white out some lines. So we're going to have x minus c to the n power over n factorial. Now, just giving you a heads up, eventually we're going to take this to infinity, and we're going to have a sum of terms. Just looking ahead, okay? So that was a Taylor polynomial, which is centered at some value c. But now we're going to get a little more specific and say, well, you know what? A lot of these are centered at 0. They have a special name named after this guy named Maclaurin. We're going to use a green pen. And so, same idea, polynomial of degree n. And it is everything you see here. However, all my c's are 0, which is going to make things a little easier. And really, for the sake of understanding the structure, I personally like to put in a lot of unnecessary things in the first couple terms. It just helps. Necessary, unnecessary, whatever you want it to be. So x to the 0 over 0 factorial. The more I write that, I say this all the time, but the more I write it, the more I remember the structure. So if you don't want to put all these things like x to the 0 over 0 factorial, totally fine, really. But the pattern holds. I have looked at things like this in the past when I was learning this, and I thought, oh, well, the pattern falls apart here if you leave those out. It doesn't fall apart. It's there. So f prime of 0, x to the 1 over 1 factorial. You can see where this is going, right? So let's go kind of fast. Second derivative evaluated at 0, x minus 0 squared. 2 factorial. Let's go one more. Third derivative evaluated at 0, x to the third over 3 factorial plus ... And we're going to end this thing at the nth derivative evaluated at 0, x to the n. I don't know why I put parentheses on that x and not the other ones, but I guess he's special because he was the last term. There it is. You are going to need to remember this structure. If you can remember this last term, you got the rest of them.